Yeah, well, maybe since I know already what I'm going to present, I can start talking a bit about it, and hopefully by that time it gets up. So I'm going to be talking about zero-knowledge use cases, and actually the last question that was asked earlier is a great segue into it, because I'm not sure how whomever asked the question meant a ZK developer, but the way I like to approach it is if we want end user use cases to be available in the industry that are enabled by zero knowledge, then I don't think we can operate in a world where everyone is accepted to learn, finite arithmetic and foreign fields and cryptography, elliptic curves and stuff like that. So that's why I'm here. That's why O1 Labs, the company I work for, is here, and we just want to abstract away all the complexity for the average application developer. But yeah, to begin with, why zero knowledge, right? Ultimately, at the very basic level, ZK, zero-knowledge proofs, are programmable cryptography that allows blockchains, the industry that we're all a part of, to outsource tasks to end users. And you can see some of the use cases that are allowed thanks to this, and I'm going to dig deeper into these in a bit. But and this is going to change, but we like to categorize them under 4 main categories, which is scalability, scaling the throughput of blockchains, privacy, allowing people to hide their private data or the details of their transactions, trustless attestations, which is basically how do you prove a fact about yourself without sharing the entire data, and verification or verifiability, which usually becomes much more relevant in this whole AI revolution that we're all having. One interesting distinction here that I want to share, especially in our Web3 space, is we think of ZK as synonymous with blockchains. That doesn't have to be the case. In fact, many of the developers that we talk to, they actually come to us and ask, especially if they're new and not from the Web3 world, okay, like ZK is great, I understand it, where do I need a blockchain? The answer is maybe you don't, right? You can just pass around these proofs peer-to-peer. So, I think it's Vitalik who said, like ZK will be as important as blockchains in 5 years, meaning there will be other stuff and it will be on par with blockchains, and there's going to be a lot of overlaps, but also a lot of differences. One important thing I think we all need to do, especially being in this industry, understand is how ZK is going to be constructed, and this is just one mental model. The best analogy in my 4.5 years in the space that I've come across is to microprocessors, where we even call these application circuits. Right, and where, like, so far I would like to think that there are 2 types of ZK applications or ZK stacks. One are hyper optimized for specific tasks. This is one thing that you see more in the rollup space, for example, where you're trying to optimize your proof system to be very specifically fast to verify on EVM chains. And then there's ones that are more focused on accessibility. And this is similar to, again, in the microprocessor space, like an x86 architecture, which allowed many application developers to start accessing the powers of the microprocessor. And here, this is where developer experience really is important. You don't want to, as I was saying earlier, force people to have to learn elliptic curves and finite field arithmetic. And these things actually can also operate. That's the beauty of it, right? You don't have to only have like hyper-optimized ZK stacks, but you can actually start lining these up each other, and then you start thinking of, okay, like how do I have an optimized proof system for whichever use case that I have in mind, and what is the programming interface that I want to expose to application developers? And then there's a way that you package these together, right? And this could end up being an L1 or an L2 or just an app, right? Or an app chain. There's many different ways to package these things together. How do we approach this at O1 Labs? We actually we're starting to consider these as multiple products that we're putting out to the space. For us, the proof system is called Kimchi. Kimchi is ultimately a Plonkish proof system, but it has various other elements from Halo 2. And then we expose one of the ways that we currently expose the programmability of this proof system is via O1JS, which is a TypeScript SDK. And then one way we package this all up together is in the layer 1 that's called Mina, right? So you end up having a blockchain that uses the Kimchi proof system that allows developers to develop applications and deploy it on the Mina chain using O1JS. And then there's all sorts of blockchain dynamics such as the Mina token and validators and whatnot that tie everything together to have an L1. Real quick about O1 Labs. We've been in this space since 2018, one of the, I would say, OGs. The Mina blockchain back in the day was called Coda, so this is actually a screenshot of the website back from 2018, so you can see the original vision, which is still the same. And launched it on mainnet in 2021, and right now we have a team of 40 ZK experts, and our focus has been to make this whole thing accessible. In fact, this is our mission as a company, to catalyze this new generation of applications thanks to this amazing technology. Real quick about why Mina, what sets it apart. It's truly a next-gen blockchain. We are starting to think about it as like a proof of everything chain, which is also like kind of the final stage of Ethereum's vision. If you look at it, it's like proofs all the way down. It is fixed size, meaning anyone can in perpetuity know that they can run a full node or a node with full node security, like even in 10 years without having to like download hundreds of gigabytes of state. ZK is a first-class primitive that allows for many types of abstractions and layer 2s to be built on this using ZK in a very easy manner. I mentioned already O1JS has this intuitive TypeScript SDK. Thanks to, again, the way ZK apps are architected, you actually do all the computation client side. So contrary to a more traditional blockchain such as Ethereum running the EVM virtual machine, where all the computation is being done by all the thousands of nodes around the world, in Mina, only one client, meaning the user's machine, does the computation, generates a proof once, and then submits that proof to the chain, and that chain just verifies the proof, which is a much simpler computation, meaning you can have unlimited computation, as powerful as your own device, laptop, whatever it is, right? So this really changes the model for how you should be thinking about gas fees and the throughput of a chain. And then, yeah, it enables privacy, meaning, again, one of the advantages of having client-side execution is you can hide your inputs or leave them public. And this, I think, is good in a regulatory world where we sadly have a lot of scrutiny from regulators, especially in other countries such as the US, where private applications are seen as a bad thing. That fight still has to be fought, but until then, until we get to a place where everyone can use private apps easily, you want to have some of the flexibility, otherwise you run into really strict issues about adoption. And then O1JS, again, this is the interface that accompanies Mina. It is a TypeScript library, meaning you don't have to learn a new language, any new syntax. It's like how you would use React to develop a web application. It does allow full recursion, infinite recursion, meaning you can create arbitrarily complex ZK applications, again, just using a TypeScript interface without having to learn all the fancy cryptography. No trusted setup is required. In many of the proof systems, you need to run a trusted setup to get an application going. With O1JS, none of that is applicable. I mentioned already that proving happens in the browser, so you don't have to run a side application on your device. And no gas fees, which I, again, already mentioned. And one of the beauties of O1JS is, as I was talking about earlier, not everyone feels the need for a blockchain, right? And with using O1JS, you can actually develop what I call peer-to-peer or off-chain applications that just pass the proofs between different devices. So that creates for a lot of flexibility. We work with a bunch of companies that are existing companies in the space that want to add ZK to their application stack. And right now we're actually building a third cohort of this. So if anyone has companies which doesn't use ZK but they want to add ZK, find me. I'm happy to put you in touch with our team. And yes, finally, I do want to dig deeper into the use cases because ultimately that's the topic of the talk. As I mentioned, I like to categorize it under these 4 categories of scalability, privacy, trustless, attestations, and verification. That being said, these are not like hard lines. There's a lot of overlap in these because ZK ultimately is a very powerful tool that you can use for various things. But for the sake of this presentation, I am going to be separating them quite a bit, and then just focusing on some of the the focuses and the applications that are getting built on Mina using O1JS, just to give you all a sense of okay, like what is possible with ZK. And as I go through this QR code at the top right, that actually takes you to a directory that lists a lot more applications. So I need my notes because there's a lot of applications here. So let's start with scalability first, and I'm going to bounce around. We have the ProtoKit team, which presented earlier, which is building an app chain framework on top of Mina, allowing apps to spin up their own L2s easily and have access to wayport throughput. BioSnarks is somewhat in the medicine development space, where they, using Mina and O1.js allows them to share the results of some of their testing and medicine development privately. They also use a lot of advanced machine language or machine learning here. And thanks to O1.js's powers, like this allows them to actually do a lot of fancy machine learning stuff. Mina NFT is an NFT platform with that allows people to do private attestations about data with them about themselves and added into the NFT metadata. Lambda class, which is actually a company, we don't have a logo for the bridge, but they're working on a bridge or a way to verify the canonical Mina proof on EVM, allowing for Mina state to be ingested at the EVM chains. Zeko is an L2 framework similar to OP Stack on the Ethereum land that allows people to easily spin up the different L2s, ZK, L2, ZK rollups on top of Mina. Anomics is a private transactions L2, so Mina doesn't have at the L1 level default privacy. That's somewhat the regulatory flexibility that I mentioned earlier. But thanks to Anomics, you can just have private transactions at an L2. Doot is a trustless oracle that allows data attestations to be signed and proven that they're from where they actually say they are. So this can be a challenge with oracles on this, like people trust you already, like maybe they trust Chainlink, but you don't want to just have one oracle provider, and that trust is spun up much easier thanks to ZK. OpenMina is how you use the initial Mina vision, which is openmina.com. Go there, and then your browser verifies the full Mina proof. So you can basically have full node access to Mina inside your browser without trusting anyone. Kalpang is a fast DEX app chain that is being built, I believe, on ProtoKit. So it allows super fast DEXs to be spun up on top of Mina. ZK Snap is, let's see, where am I? Oh yeah, is a private DAO voting initiative. So you can basically, many DAOs vote on the various proposals, but they're all public. So this can cause a bunch of issues, but if you can make the votes private, that's a lot better. Lumina is a permission, AML permission DEX that is getting built on Mina, meaning this can actually have regulatory, can be viewed in a much more friendly light by regulators. ZK database is a database solution that has verifiable calls from that database, so you can prove the types of queries that you're doing from the database, meaning you get a lot more verifiability. Snickerdoodle is private cookies, meaning you can actually share insights about who you are, what you're doing on in your browser with ad providers, but in a private way. ZK Humans is working on a private universal identity, so you can just have one identifier, but do it in a private way, like about who you are, so you don't disclose confidential data. ZK Wallet is a wallet on Mina that is seedless. Thanks to ZK, you can just verify your 2FA without having to associate it with a seed. So it allows you to basically just not lose your seed, which is a problem. VaultMe is private file sharing. So this allows, like in a directory for private files, this allows you to basically, just share files without other people without disclosing this on a public network like Mina. So it allows the Mina blockchain to have data about anonymous files. ZKP ID is a global KYC solution. They actually partner with Lumina to provide the KYC layer such that Lumina can be AML compliant. DIA is a verifiable Oracle model, so they use custom models for oracles to have custom data feeds, and kind of in a machine learning way, they can, using Mina and O1.js, they can verify that they didn't trick anyone with how they're constructing the models. Punkpol is a existing company based in Korea. They are a DAO provider or operator, and they want to run surveys into both their DAOs as well as other people out there and do this in a private way. So as a survey taker, you don't need to share how you're responding to the survey. Well, you do, but it stays private. Veridis is working on a proof of liability solution. So this became a huge issue, right, with FTX failing. Many people talked about proof of assets, but without the liabilities, this doesn't actually mean anything. So that's what Veridis is building. And finally, I'm out of breath. Snarky ML as a ML framework that's built on top of O1.js to make constructing machine learning models using O1.js a whole lot easier in our day of AI. This is very important. There's a whole lot more, as I said, use a QR code, things people are building such as private auctions or private games such as poker. So yes, this was a lot, I know, but I just wanted to give a sense of all the amazing use cases possible with ZK. And we're only scratching the surface. None of these are in production yet, right? Or pretty much not yet. And we're seeing a whole lot more ideas as people come by, where developers, thanks to how easy it is to use O1.js, they are starting to imagine a lot more things because they don't have to invest into learning all of the cryptography. Instead, they focus on their creativity and the types of use cases that they want to test with their users. Finally, yeah, because of all this innovation that is finally starting to happen, I do believe that 2024 is going to be a momentous year for ZK, kind of like how 2023 was for the scalability applications, especially with Ethereum rollups, all the ZK rollups and ZK VMs coming online. I do believe that next year we're going to see a whole lot more use cases, some of which start getting a lot of users in production. And finally, like every new secular cycle in the Web3 space started with a new use case. I do believe that ZK is going to start the next excitement cycle into the space because it's really going to enable a lot more flexible use cases, not only for speculators or not only for airdrop mining or farming, but actually sustainable use cases that people want to use thanks to blockchains and the power of ZK. Yeah, so that's all I had to say. I think I have a few more minutes still. Happy to take any questions, or if anyone wants to dig deeper, that's the O1 Labs website, so check it out.